The topic is rational exponents. Do you remember about the symbol that appears on the theory? Okay, it's used to indicate roots. The index is the small number that you have to the left of the radical symbol that tells you which root to take. Okay, for example, if you have a 3 in the index of the root, this is going to represent a cube root. Another way to write n roots is by using exponents that are fractions, okay? For example, okay, you have a little demonstration below, but we are going to start solving the first exercise so you can see it better when you have, okay, the example. So the definition of this formula that you are going to use for the exponents with fractions is that a number raised to the power of 1 over n is equal to the nth root of that number, okay? So then if you have, for example, b to the power of 1/2, then b is going to be inside a square root because you have the denominator of the fraction is going to be the part that you write in the index, okay? In the index of the root, you write the denominator of the fraction. Then the first example is about to simplify two exercises that they write in here. And later we have another formula. Okay, so if we need to simplify each expression, we need to simplify this, okay? So I'm going to write 125 to the power of 1/3. This is exercise A. 125 to the power of 1/3. Okay, then you are going to write inside the root, the 125, only that you are going to write the number 3 in the index. So what you have is this, the cube root of 125. And then if you want to simplify more, we are going to try to see if there's one number that multiplied 3 times is going to be equal 125. Okay, so one number that multiplied 3 times is going to be 125, is going to be equal 5. So cube root of 5 to the power of 3. Remember that the exponent, the idea is that the exponent could be the same that we have for this number and the same index for the root. So we can eliminate. When we have the same exponent and the same index for the root, we can take away the square of the cube root, okay? So we eliminate the exponent with the index of the root. So we have that the answer for this one is equal 5. Okay, so this number that you have on the denominator in the fraction exponent, okay, in the rational exponent, is what is going to tell you the index for the root, okay? So in the example number 2, you can see that it's the same, only that we have a addition. So we are going to solve one by one and later we add the results that we obtain, okay? So 64 to the power of 1/6 plus 25 to the power of 1/2. So it's 64 for exercise B is 64 to the power of 1/6 plus 25 to the power of 1/2. Okay. Then we are going to write the numbers inside the roots. This is going to be a sixth root, and this is going to be a square root. Then you write the sixth root of 64 plus the square root of 25. Okay, remember that when it's only the square root, I don't need to write the exponent, okay? I don't need to write the index, sorry. We only write the root without any index, and we know that is going to be a square root for this one, okay? So what I need to do now to simplify is to check if exists one number, there is one number that multiplied 6 times is going to be 64. In this case, the number that multiplies 6 times is going to be equal 64 is going to be 2. You can try, if you are not completely sure about what number to choose, you can try it on your calculator. For example, you can try with 2 to the power of 6, or 3 to the power of 6, 4 to the power of 6, okay? I'm talking, for example, when you have a greater number than this, and you are not completely sure what number are you going to replace. So you try with many numbers until you find the answer. If you find one result that is closer to this one, but it's not the same, then you are going to know that what is inside the root doesn't have any, okay, doesn't have a perfect square or perfect cube, okay, depending on what you need. So in this case, one number that multiplies 6 times is going to be equal to 64 is the number 2. So inside the 6th root, we have 2 to the power of 6. We can take away the 6th root and the exponent plus the square root of 5 to the power of 2. Okay, so we can take away this with this exponent. And we only have 2 plus 5 because we eliminate the roots. So we only have 2 plus 5 equal 7. So that's the reason why you obtain 7 in the result. Because you can eliminate the square root and the 6th root only if inside the root you have the number with the same exponent, okay, the same index and the same exponent. Only in that way you can eliminate, okay. If the exponent is different, no. If the exponent and the index are different, you can eliminate anything, okay. So this about this first example. We have 2 parts, A and B. Now you can go to the page 399. You have the other definition. Definition of m to the power of b, to the power of m over n. What is the difference in here? You are going to have a fraction too. Only that in this fraction, we don't have a 1 on the numerator. We have other number. We can have other numbers in the numerator. And this is going to be a power of, okay, depending on the number. For example, in the first one, you have in the example in the chart 8 to the power of 2/3. And you can see that 3, okay, the number 3 that is in the denominator is going to be the index of the root. In that part is the same. Only that after we solve this part with the index, we are going to use the other number in the numerator as a exponent, okay, to the expression that I have inside the parentheses. So we are going to use the first option. You can see that there are 2 lines, 2 different ways to solve the same exercise. We are going to use the first one, okay? It's the way that uses the book. So we are going to use the first one because you don't get confused with this. If we use the second one, maybe it could be more confused for you because you have the exponent inside the root with the other number. So, okay, I prefer to do it first we solve the root, and later we solve with the other exponent that we have, okay? So in the number 2, to simplify expressions with fractional exponents, we have the first example, 216 to the power of 2 over 3, okay? So we are going to solve this one. I just need to erase the board. I just need to erase in this part. Okay, so we have 216 to the power of 2 over 3. Okay, then immediately you see this, you know that this is going to be the index of your root, okay? So you have the cube root of 216, okay? This is the cube root. And later, outside the parentheses, you are going to have the exponent, okay? 2, the number that is in the numerator. In this one, for example, why don't we write the exponent? Because it's 1, and so it's not going to affect anything, okay? So that's the reason why when the numerator is 1, it's not necessary to write it. But in here, yes, because the 2 is going to be a change in the operation that you are going to solve. So you write the parentheses and you write the power of 2. So then, remember, we need to identify if the index could be eliminated. So we need to try if there is one number that multiplied 3 times could be equal to 216, okay? So in this case, we know that if we multiply 6 3 times, 6 times 6 is 36, and 36 times 6 is going to be 216, okay? Again, I told you, if you are not sure what number to use, you try it on your calculator. On your calculator, you can, is this form 6 to the power of 3. There is a symbol that appears to show the power of, okay? So 6 to the power of 3. Or for example, you can try with other number, 7 to the power of 3. If you are not sure what is the number, you start trying with many of them until you find the answer. If you could find it, for example, 7 and 8, 9, okay? If you couldn't find the number, it's because there is no, like in here, for example, there's no perfect cube. But for the example A, we know that if we have 6 to the power of 3, it's going to be a perfect cube. So I'm talking, for example, for other cases when you don't have, okay, that you need to try. But in this case, we already know that yes, it has a solution. So 6 to the power of 3, and the exponent is outside. Look that we are keeping the exponent outside because we are going to solve it until the end, okay? Until we don't have anything inside here. So I can take away this, the cube root with the exponent because they are the same. So the result that I obtain is 6 to the power of 2. Look that I eliminate the cube root.
Mister,
Mm-hmm.
dice Méndez que Zoom lo sacó, entonces que si lo puede volver a aceptar.
Now I'm watching. Okay, I'm seeing him on the waiting room. Okay. Then 6 to the power of 2. Remember, it's only 6 times 6. Okay. So 6 to the power of 2.
Sorry, Mister. But why is 6?
You try, for example, this, we know that is 6 because, okay, we already know it's, okay, already solved. But if you are not sure what number is, you have 216. This is the number that you want to identify If there is one number that multiplies 3 times, it's going to be equal to 216, but you are not completely sure what number to use. So you can start trying on your calculator, for example, with the number 2 to the power of 3. We try and we see that is not. Okay, I'm going to use the calculator, guys, because if I wait for you to solve it, we are going to take more time. Okay, so 2 to the power of 3 is going to be 8. Then I know that this number is not even closer. We have 216. So I can try, for example, 4 to the power of 3 is 64. Okay, but we need more. Okay, I know that 5 to the power of 3 is not, because when you multiply by 5, the last number has to end with 5 or 0. In this case, is not, so we don't even waste time trying with 5. Okay, but if you want to try again, 5 to the power of 3 is 125. Okay, so you can understand the idea. You are trying with many numbers, okay? And you are getting closer, but you need more. So, for example, we need to try with 6 to the power of 3. Then in this case, you identify that is 216. Okay, so this is the idea. You are trying with many numbers until you find the one that you need. If, for example, the number is not 216, we can say that is 218. And when you try with this, you obtain this is closer, but it's not the same. So you can say that there's no perfect cube, so you cannot eliminate the root. You cannot take away the cube root. So you understand the idea, you try. But in this case, we know that yes, this is a perfect cube because when you write 6 to the power of 3 is the same that we have inside the root, okay? So we only solve the exercise B and we can finish for today. Later I'm going to give you some time if you want to ask something more. About this part is clear, about the exponents, okay? I think, so I'm going to eliminate this, erase, so we can try the other example. Okay, so for the example B, we have 32 to the power of 4/5. Okay, so again, the denominator is going to be the index of the root, so it's the 5th root. It's the 5th root of 32, and this is inside parentheses because we need to write the exponent that is going to be the numerator of the fraction. So to the power of 4. But remember that the exponent, we solve it until the end. First, we work with the numbers that we have inside the root. Okay. So again, you identify one number that multiplies 5 times is going to be equal 32. So you start trying with 2 to the power of 5, and you can see that yes, that's the number. Okay, so you start trying with 1. Doesn't have any logic to try because you know that 1 to the power of 5 is going to be 1. So 2 to the power of 5 is 32. Then we are going to replace. Okay, you identify that 2 to the power of 5 is 32, so you replace 5 2 to the power of 5 and this to the power of 4. So you can take away the square root, fifth root, sorry, with the 5 exponents, okay? Then you only obtain the number 2, okay? But the exponent 4 that you have outside the parentheses, you write it, okay? And then what is the result for 2 to the power of 4? You multiply 2 times 2 times 2 times 2, okay? Obviously, you are not going to do this, all this when you have a bigger number, for example, to the power of 7, to the power of 8. Again, you use your calculator. There is one reason why some people invented that little machine, so you can use it, okay? 2 to the power of 4 is going to be equal 16, okay? What I need you to understand is this part and how to work with all the index and the exponents, okay? But when you have something like this, you can use perfectly the calculator to obtain the final answer, okay? And to try what number are you going to write inside the root, okay? So for example, if this is a 7th root, you need to identify what number multiplied 7 times is going to be equal what you have inside, okay? Depending on the index that you have. Okay, so that's it for the first 2 examples. They have 2 parts, A and B, each one. I don't know if you have any other question about this or if we can finish in here, because for the 2 examples we already finished, okay? So if you don't have any other question, we can, okay, I'm going to finish recording the class.